One thing we want to look at is what's called incomplete dominance. And with incomplete dominance, the only difference between this and a normal Punnett square is that when you have an individual who is heterozygous, remember heterozygous, meaning we have one big and one small allele, and in some cases they're going to use two different letters when we look at incomplete dominance. So that's kind of a tip-off is how you know this. But when it is incomplete, the heterozygous individual expresses its own unique phenotype. All right, so for example, we look at snapdragons, all right, or hair color or hair length. Let's look at snapdragon color because that's one that's commonly used. So dominant, let's just use R's, all right. Two dominant would be red, okay. If you have two, and they use different letters for these sometimes, and that's what we're going to use here. Two W's, it would be white. But if you have an R and a W, now normally, because if R is the dominant trait, it will be red. But because it's incompletely dominant, this is going to appear pink. Okay? And that's the big difference between regular Mendelian basic Punnett squares, regular dominant recessive, and then incomplete dominance. And the way you know it's incompletely dominant, it will tell you it's incompletely dominant, and it will also tell you what the middle phenotype is. So it'll tell you, when we get red and white, we cross and we get pink, that sort of thing. So there are a couple ways that you can go through and determine if it is incompletely dominant. Let's look at a couple of practice problems here. The first one states that the color red in snapdragons is incompletely dominant to white. Heterozygous organisms are pink, cross two pink flowers. So let's go through here and see what we got. Red is incompletely dominant to white, and that heterozygous are pink. And we need to cross two pink flowers. So, again, very much like the last one, we're going to pick two different letters here. So the R allele will be red, and the W allele, all right, will be white, because red is incompletely dominant to white. So if they're heterozygous, remember they have one of each allele, and we're going to cross two pink flowers. We're going to cross two heterozygous organisms. So we're going to cross RW with RW, all right? And so we go through this, drawing out our Punnett square. Again, put each allele in its proper box and cross them. Again, the process is very similar. The only difference is that our heterozygous individual expresses its own phenotype, all right? And we're using two different letters. Now with these, I'm only going to ask for phenotype. So tell me, what are they going to look like? How many of these are going to be red? We're going to have one red flower. We're going to have two pink flowers, right? Because those are heterozygous. And homozygous recessive, or white flowers, we're going to have one. It's just that simple. It's the same process. The only difference, though, is that we have an extra phenotype we need to look at. We have an extra color. Red would be big R, white, little, or WW, and then pink would be R and W. They're the heterozygous individuals for this particular trait, all right? So make sure you understand this as you go through. Incomplete dominance is different because the heterozygous individual, that is the one with two different alleles, expresses its own phenotype. It doesn't look dominant, it doesn't look recessive, it looks somewhere in between. Okay? Let's look at our next problem. Cross a red flower with a white flower. So, if we remember, big R and W, got red and white. We're going to cross a red flower with a white flower. And again, the more practice you get with this, the more you can kind of sit here and think about what you're going to get. Sometimes you don't even have to do the Punnett square. I still want you to do them to show me that you can, but sometimes you can just look at them and predict what you're going to get. Okay? Looking at your phenotype, how many red? how many pink, and how many white. Okay? Red, pink, white. All right? Red, pink, white. Just in that order. So homozygous dominant, heterozygous, homozygous recessive. That's all you have to do. All right? Last practice problem says we want to cross a red and pink flower. I'm not going to write down the alleles because I'm hoping that you remember them. What's a red flower going to be here? Big R, and pink, big R, and W. And again, same process as before. Made that one a little big, didn't I? Cross your alleles. My R's look horrible, don't they? I tried, folks. Okay. Phenotype. How many are going to be red? How many are pink? And how many will be white? And that's all there is to it, okay? So you can express these however you want, but just make sure you understand the big difference here. When you have something that has a heterozygous individual, all right, expresses its own phenotype. That's why you have the extra one there. So ones that express the dominant, remember, it's incompletely dominant. So when you have a heterozygous individual, it has its own color. Dominant's red, big R is red, big W is white, somewhere in between, we got pink, all right? This works for other traits as well. We'll talk more about them a little bit later on. Best of luck to you guys. Go through the practice problems, and if you have any help, if you need any help, make sure you let me know. Have a great day, guys. We'll talk to you later.